Hello everyone, what's up? Today is day 18. We're working on the chain rule. The chain rule of derivatives is one of the most important rules that we will learn, and it is by far the most commonly tested derivative rule on the exam. It's going to come up over and over and over again. So, buckle up. Today's video might be a little bit longer, but it's going to be so important. This will be a good video to go back to later on if you're struggling to remember how to do the chain rule. The chain rule really probably should be called the composition rule, because it's what we do when we take the derivative of a composition of two functions. So like f of g of x or g of f of x. So let's take a look at the chain rule in its basic general form, which will help us to solve problems along the way. So what we're looking at here is the derivative of a composition of functions. So we have a function g of x, which is composed in another function f of x. Notice this is not f of x times g of x. That would be the product rule. This is f of g of x. Now the general rule with the chain rule is that I like to think of g of x as my inner function, f of x as my outer function. And the chain rule in words is going to be the derivative of the outside with respect to the inside times the derivative of the inside. So it's going to look like this. So we end up with the derivative of the outer function, f. So it's f prime of g of x. Notice that that inner function remains the same. We do the derivative of the outer function with respect to the inner function, and then we multiply by the derivative of the inner function. So we're going to have both g and g prime showing up in our answers. So again, in words. Derivative of outside with respect to inner function, the inside function, times derivative of the inner function. That times g prime of x, I like to call it tacking on g prime. That's where the chain comes from. It makes a chain. So we do the derivative of the outside with respect to the inside times the derivative of the inside. We tack on that g prime of x, that inner function g prime. Okay? So that's our basic setup here. And I'm just going to do a bunch of examples to help illustrate this problem. Okay, or this rule. So our first function is f of x equals sine of the quantity x cubed. Notice this is not sine of x whole thing cubed. It's only the x that is being cubed. So what we want to do is kind of identify what is our inner function, what is our outer function, to kind of get a handle on this, right? So our inner function here is x cubed. Our outer function here is sine x. So sine is our outer function, x cubed is our inner function. Okay? If we wanted to write this as two separate functions and do a composition, think back to your pre-calc days, right? If I let h of x equal x cubed, and I let g of x equal sine x, then g of h of x so then g of h of x would be sine of, and we're replacing x in g of x with h of x, which is x cubed. Right? So we can see that our inner function here is x cubed, our outer function here is sine x. So now let's talk about finding f prime. So our goal is we want to find f prime of x. So following the chain rule, we say, I want to do the derivative of the outer function. What is the derivative of sine? Well, the derivative of sine is cosine. But I do the derivative of the outside with respect to the inside. So I end up with cosine of x cubed. That right there is the derivative of the outside with respect to the inside. But remember, we always have to tack on in the chain rule. We're going to tack on the derivative of that inner function. Well, what's the inner function is x cubed. What's the derivative of x cubed? Well, that's simply times 3x squared. To clean this thing up, right, I always like to write polynomial stuff in front of trig stuff. So I would say 3x squared cosine of x cubed. And there, we've done our first chain rule derivative. Okay? Let's take a look at another function that's going to look just kind of the same, but very different. It's going to have a very different answer. We see all the same letters and numbers here, but this is a very different function. If we look at this, this is sine, we would read this as sine cubed x, but another way you could think about this is we're now, what we're cubing now is now the whole function sine of x. So another way of writing sine cubed x that might be helpful for us here is write it as sine of x in parentheses, then cube the whole thing. When we write it like this, it's going to be easier to identify the inner function and the outer function. When we look at it written as sine of x in parentheses to the third power, we can see that sine x is our inner function. And x cubed is our outer function. Right, again, if I wanted to write this as a composition, I could write g of x equals sine x, and I could write f of x equals x cubed. Then f of g of x would be sine of x to the third power. So again, I want to do the derivative of the outer function, but when I do this derivative of the outer function, I want to do it with respect to the inner function. So when I think about this, I know that the derivative of x cubed is 3x squared, but that's the derivative with respect to x. I want to do the derivative with respect to the inside. So watch how this works. So what I get here is the derivative of the outside, which is, right, if it was x cubed, it'd be 3x squared. Since it's sine cubed, it's 3 sine squared. Right? It's the derivative of the outside, that would be the 3 and the 2, with respect to the inner function, which is sine of x. But don't forget, in chain rule, I always have to tack on. What I need to multiply by is the derivative of the inside. Well, our inner function is sine, so our derivative would be cosine x. A lot of students forget to tack on the inner function derivative. So don't forget to do that. So we end up with 3, simplifying this. Simplifying this, I get 3 sine squared x cos x. Okay? Again, sometimes we think of it as, think of the inner function as stuff. So in this problem, we have stuffed cubed. Our derivative will be 3 stuff squared d stuff, derivative of the stuff. Okay. By the way, if you're at the point now where you're like, I don't know what's going on, don't worry. The chain rule takes a long time to really grasp it well. So keep doing these problems, keep thinking about it, and eventually this will click. Let's try another function. I'm going to try this function. So take a look at this function. We see we are doing the square root of the quantity 4x squared plus 5. So right now we have an inner function and an outer function. What I want you to do is guess, what are we going to refer to as the inner function here? Well, the inner function is going to be 4x squared plus 5. What's the outer function, you ask? Well, that's just the square root of x. So what we have here is we have 4x squared plus 5, and we're taking the square root of that. The square root is acting as our outer function. 4x squared plus 5 is acting as our inner function. Now, just like when we worked with square roots with the power rule, it's going to be important to rewrite f of x here before we start doing the chain rule. So we can see f of x can be written as 4x squared plus 5 to the half power. That should be nothing new to us. We know that square root means half power. So right now we have stuff to the half power. Our derivative will be half stuff to the negative half power times the derivative of the stuff times d stuff. So let's take a look. Right. I'm taking that half power, I'm throwing it out front, keeping the inside the same. I have to keep that inside the same because it's the derivative of the outside with respect to the inside. I don't do the derivative of the inside yet. I now have to multiply by the derivative of the inside. So what am I going to multiply this whole thing by? So I'm going to multiply the whole thing by 8x. Now this is right. This is our answer to our derivative here, but I'm going to write it in a more friendly way to look at it. Okay. Now I see that I have 4x squared plus 5. That's to the negative half power. I'm going to want to put that in the denominator. And I already have something in the denominator. I have the 2. So the 2 from my half and the 4x squared plus 5 to the negative half, I'm going to move them and put them on the bottom. And when I move that 4x squared plus 5 to the denominator, I have to change that sign to a positive half. I can do one more step to make this thing a little bit nicer, a little bit easier to evaluate if we need to. Right, that 8 and that 2 will simplify to a 4 and a 1. I'm also going to write this back into the original context of the problem with using a square root. And you can see here I get a very nice simplified answer of 4x over the square root of 4x squared plus 5. Okay? If that 8 and that 2 wouldn't have reduced, that's fine. I could have just left them there. But they did reduce, so I reduced them. Let's try another one. So now I have f of x equals the natural log of 8x plus 1. Okay, so what I want to think about here is what's my inner function, what's my outer function? So go ahead and take a guess. What's the inner function? My inner function is 8x plus 1. What's my outer function? The natural log of x. So let's now talk about finding f prime. So I want to do the derivative of the outside. Well, now let's think. Natural log. I know the derivative of natural log x is 1 over x. But now I'm doing the derivative of the natural log of 8x plus 1. Okay? So I have to do the derivative of the outside, but instead of with respect to x like we're used to, I'm doing it with respect to 8x plus 1. So what I end up with is not 1 over x, but 1 over the inner function. So this is f prime of g, the derivative of the outside with respect to the inside. 1 over 8x plus 1. That's the derivative of the outside with respect to the inside. Notice 1 over x never showed up. All right, think of it as this way. Natural log x derivative is 1 over x. Natural log stuff derivative is 1 over stuff. But I need to multiply by one more thing. Don't forget to multiply by the derivative of the inside. Well, what is the derivative of our inner function? Well, it's simply 8. So natural log stuff, that derivative is 1 over stuff times stuff prime, the derivative of the stuff. So I have 1 over 8x plus 1 times 8, which was the derivative of the inside. I simplify that nicely to just call it 8 over 8x plus 1. Note that I can't reduce that, I can't cancel those 8s because of that plus a 1 at the end. Okay? Next. So f of x now equals e to the x squared plus 5. Again, what's my inner function? What's my outer function? Well, my inner function here, again, is x squared plus 5. So again, I have my inner function of x squared plus 5, my outer function of e to the x. Well, I know e to the x's derivative is e to the x. But that's when we just had a normal, regular old x up there. We don't anymore. We have x squared plus 5. So I have to do the derivative of the outside, but I have to do it with respect to the inside. So I'm going to have to do e to the x squared plus 5. Anytime we have an e derivative, we end up just rewriting our original function. So the derivative of the outside is e, but it is e with respect to the inner function. This is the derivative of the outside with respect to the inside. All I have to do now is multiply by the derivative of the inside. Don't forget to tack on your chain rule. So I need to multiply by the derivative of x squared plus 5. The derivative of x squared plus 5 is 2x. Rewriting this thing, I get f prime of x equals 2x e to the x squared plus 5. Let's try one more before I try something really crazy. So I have the function f of x equals sine of negative x. Well, what's my inner function? Negative x. My outer function is sine. So I do the derivative of the outside with respect to the inside and multiply by the derivative of the inside. The derivative of the inside is, the derivative of negative x is negative 1. And I get that. Let's just try, let's take a look at, we'll do more examples like this in class tomorrow. But I want to look at, what if I have a function within a function within a function? That's not the Wi-Fi symbol you're seeing. That's just a whole bunch of parentheses. So what we have here is a function h of x within a function g of x within another function f of x, and we're trying to take the derivative of it. Sometimes I call this chainception. Sometimes I call it two chains, because we got to do two chain rules on it. So here's what happens. I do the derivative of the outer function with respect to the inner function. Well, my outermost function is f, so I do f prime, but I do that with respect to the inner function, which is g of h of x. If I do the derivative of the outside with respect to the inside. But the chain rule says now I have to multiply by the derivative of the inside. Well, the derivative of the inside is not another chain rule. That's why I call it two chains, because you have to do two chain rules. So what would the derivative of g of h of x be? Well, it would be the derivative of the outside with respect to the inside. Times the derivative of the inside. So what I get is f prime of g of h of x times g prime of h of x times h prime. We just keep doing the chain rule until we have no more compositions on our inner function. Crazy, right? Let me show you one example. And I do see two chains done on the AP test, so just be aware it's definitely out there. So here, I'll give you one example with this, and then we will stop for today. So here's what I have. I'm looking at a function called cosine cubed of 4x. Now, let's rewrite this thing. That cosine cubed, it's going to be helpful to think of it as the whole cosine of 4x, that whole thing cubed. So let's rewrite this thing as cosine of 4x, that quantity cubed. And take a look. I have three different functions here. I want to find my innermost, my one in the middle, and my outermost, right? So 4x is the innermost, cosine is the one in the middle, and x cubed is the one on the very outside. So what I want to do here when I do f prime is I want to do the derivative of the outside with respect to the inside times the derivative of the inside. So the first thing I'm going to start with is doing the derivative of my outermost function. So that's going to look like this. So that's the derivative of the outside. I take that exponent of 3, it's just a power rule, multiply it out front. But remember, it's the derivative of the outside with respect to the inside. So that inner function of cosine 4x has to stay the same. I'm not doing its derivative yet. So I have 3 cosine of 4x squared. But now I need to do the derivative of the inside. But as we notice, the derivative of the inside is another chain rule. Hence, 2 chains. So of my cosine 4x, I can see that 4x is the inner term, cosine is the outer term. So I want to do the derivative of the outside, which is negative sine with respect to the inside. But I need to do one more, I need to tack on one more chain. The extra chain is the derivative of 4x, which is simply 4. And there we have it. That's the answer. I definitely want to clean this thing up because it's pretty ugly right now. So here's what I'm going to do. I'm going to take all of my coefficients, which are 3, -1, and 4. I'm going to multiply those together to get -12. Okay? Then I have a cosine squared of 4x times sine of 4x. On the multiple choice section of the test, this is how that answer would be written. So we got to be able to go from our first unsimplified answer to a nice, pretty looking f prime function. That's it for today. I know it's a lot. We'll practice it a lot. We'll do multiple days with the chain rule. Okay, it's a lot more difficult than product and quotient, but it's tested more, so we want to be really good at it. I'll see you guys tomorrow.